Welcome to Do the Math America. I am Charlene Math Shaman.
This is Lesson 14, Number Properties. We work out of the beginning algebra book, pages 25 through 27. Please use the link for the PDF file of this textbook in the description box below this video to make a hard copy of this textbook for yourself. It is out of print and no longer available for purchase. My lessons 7 through 47 are from this textbook. So, number properties. An axiom or postulate is a statement we assume to be true without proof. These properties are observed to be true, and we know them through just logical thinking and common sense, as well as through working with numbers. For all real numbers, A, B, and C, we have number 1, reflexive property, A equals A. Number 2, symmetric property. If A equals B, then B equals A. Number 3, transitive property. If A equals B and B equals C, then A equals C. Number 4, substitution property. If A equals B, then A can be replaced by B. Number 5, commutative property. A plus B equals B plus A, and A times B equals B times A. Number 6, associative property. A plus B added first plus C equals A plus B plus C added first, and A times B first multiplied by C equals B times C multiplied first and then times A. Number 7, distributive property. A, open parenthesis, B plus C, close parenthesis, equals A times B plus A times C. And, open parenthesis, B plus C, close parenthesis, times A equals B times A plus C times A, which equals AB plus AC. Number 8, multiplicative property of 0. A times 0 equals 0, and 0 times A equals 0. Number 9, additive identity property. A plus 0 equals A, and 0 plus A equals A. Number 10, multiplicative identity property. A times 1 equals A, and 1 times A equals A. Number 11, addition property of equality. If A equals B, then A plus C equals B plus C. Number 12, subtraction property of equality. If A equals B, then A minus C equals B minus C. Number 13, multiplication property of equality. If A equals B, then A times C equals B times C. Number 14, division property of equality. If A equals B and C does not equal 0, then A divided by C equals B divided by C. Number 15, additive inverse, axiom of opposites. A plus negative A equals 0. Number 16, multiplication inverse, axiom of reciprocals. If A does not equal 0, then A times 1 over A equals 1. Number 17, property of the opposite of a sum. Negative, open parenthesis, A plus B, close parenthesis, equals negative A in parenthesis plus negative B in parenthesis. Number 18, property of the reciprocal of a product. If A does not equal 0 and B does not equal 0, then 1 over A times B equals 1 over A times 1 over B. We will discuss this property more in future videos. And finally, we have number 19, property of proportions. If A over B equals C over D, then A times D equals B times C. The cross products are equal. And again, this property we will discuss in greater detail in future videos. Now I will demonstrate a few practice problems from the chapter exercises on pages 25 and 26. Please take the time to tackle many of these problems. It will help reinforce the lessons we worked on earlier. I'm just copying down the classification chart from page 9 so that we can get started on some of the exercises that are on page 25. We are to classify each of the following numbers according to categories. So the number 20 is categorized as a real number, a rational number, and as an integer, a positive integer. Problem number 11, the number 37 is also a real number, a rational number, and an integer. Answer the following questions regarding the number line. Number 21, what is the number whose distance is 5 to the left of 12? So we draw out the number line and we write out 0 on the number line. And we draw out the points from 1 through 12. Mark 12 on the number line and then count 5 units to the left, ending up at 7. Problem 31. What is the midpoint between -1 and -8? So first we draw out the number line and we mark where the 0 is and -1 through -8. Now we mark -1 and -8 on the number line and we count how many units are between those 2 points. And we see there are 7 units between -1 and -8. So to find the midpoint, we divide 7 by 2, and 7 divided by 2 is 3.5. So now we must mark out 3.5 units over from -8 to -1. We count over 3.5 units from -8, and we end up between -5 and -4, which would be -4.5. Compare each pair of numbers using the symbols less than, greater than, or equal to. Number 41, we compare -2 and -2, and -2 equals -2. Round each number to the nearest tenth and hundredth. Problem number 51, 45.362. So the nearest tenth would be where the digit 3 is. And we look to the next digit to the right, which is 6. And 6 is greater than 5, so we need to round up. So the nearest tenth would be 45.4. To find the nearest hundredth, we look at the digit 6. And since the next digit over to the right is 2, which is less than 5, we need to round down. So the nearest hundredth would be 45.36. Problem 61. Round 2,365,467,939 to the nearest 100 million. So we find our 100 million place value. So 9 is the 100 value, 4 is the 100,000 value, 3 is the 100 million place value. We look at the digit to the right of that, 3, and that would be 6, which is greater than 5, so we need to round up. Nearest 100 million would then be 2,400,000,000. And box your answer. Evaluate each expression. Number 71, 4 plus negative 6. When you're adding integers and the signs are different, you treat it as a subtraction problem. The number with the larger absolute value gives its sign. 6 minus 4 equals 2. The answer is negative 2. Number 81, 4 plus absolute value of negative 6 minus negative 2. We simplify. The absolute value of negative 6 is 6, and then we copy down the rest of the problem. 4 plus 6 minus negative 2. And we do addition subtraction from left to right. So first we look at 4 plus 6, which equals 10. Bring down the rest of the equation from above, so now we have 10 minus negative 2. When subtracting integers, we add the opposite. So now we have 10 plus 2, which equals 12. And we box the answer. Number 91, 32 times 2 divided by negative 8 times 3. We copy down the problem, make sure we get all the digits and the operations and the signs, and we spread out our work. Write down the order of operations to the side as a reference. So 1 brackets, 2 exponents, 3 multiplication division, 4 addition subtraction. To the problem, I see I have just multiplication and division, and I must do those from left to right. So first, 32 times 2. 2 times 2 is 4, 2 times 3 is 6. So that's 64. Write down the rest of the equation. 64 divided by negative 8 times 3. Now I do 64 divided by negative 8. So 64 divided by negative 8 will be a negative 8. Write that beneath 64 divided by negative 8 in the equation and bring down times 3. So finally we have negative 8 times 3 will be a negative 24. Box your answer. Problem 101. 6 minus 3 times 4 plus 8 divided by 2. Copy down the problem, spread it out, get all the numbers and symbols copied down correctly, and write the order of operations to the side as a reference. We're ready to look at the problem, and our first multiplication is 3 times 4, which is 12. We write down 12 and copy down the rest of the problem. Make sure to get all the symbols and the numbers written properly. And now our next computation to look at is 8 divided by 2, which is 4. Now bring down the rest of the equation and all the symbols. And now we're looking at 6 minus 12 plus 4. We work from left to right, so 6 minus 12. 6 minus 12, write that to the side. When we're subtracting integers, we add the opposite. So now we're looking at 6 plus negative 12. When we're adding integers with opposite signs, we treat it as a subtraction problem. Number with a larger absolute value gives its sign, so the answer is negative 6. Back to the equation, we write down negative 6 under 6 minus 12, and then we bring down the rest of the equation plus 4. So now we are looking at negative 6 plus 4. When we're adding integers with the opposite sign, we treat it as a subtraction problem. Larger number gives the sign. So it's 6 minus 4 equals 2. The answer is negative 2. Problem 111. 7 minus 5 times 4 minus 3 minus 1 times 2 to the fourth power minus 30. We write down the order of operations to the side as to use as a reference. And now we're ready to work on the problem. We copy down the problem, keeping all the symbols, all the brackets, and make sure to give plenty of space between each character. We don't want to crowd our work. Make sure we keep all the brackets. And we see that we have multiple brackets. We have to work with the innermost bracket first. So that would be 3 minus 1. 3 minus 1 simplifies to 2. We write down the 2. And then we copy down the rest of the problem, bring it down to the next row, making sure we get all the symbols, all the brackets, all the operation signs, all the digits, all the characters. Okay, now we look at the brackets and we see the innermost bracket has an exponent. So we work on the exponent within the innermost bracket first. So 2 to the fourth power is 2 times 2 times 2 times 2. And we multiply that all out. We have 4 times 4, which equals 16. So 2 to the fourth power is 16. We write down 16 underneath 2 to the fourth power, and then we bring down the rest of the equation, keeping all the brackets, all the symbols, all the operation signs, all the numbers. Write everything down nice and clearly. And now we have a bracket within a bracket, 4 minus 2 times 16. So within that bracket, we need to do the multiplication first. So 2 times 16, work that on the side if you need to. 2 times 16 equals 32. And we write that down underneath 2 times 16, and then we bring down the rest of the equation, all the brackets, all the operations, all the numbers, all the symbols. Okay, now we have a bracket within the bracket, 4 minus 32. So do that on the side, and 4 minus 32. When you are subtracting integers, you add the opposite. So now you have 4 plus negative 32. When you add integers with opposite signs, you treat it as a subtraction problem and take the sign of the number with the larger absolute value. So it is a negative 28. So under 4 minus 32, we write negative 28. We write down the brackets around it and bring down the rest of the equation from above. All the symbols, all the operation signs, all the numbers. Okay, now we look at the problem. We see there's a bracket we must do first. Within the bracket there is a multiplication which we must do before the subtraction. So 5 times negative 28. We do that calculation on the side, out of the way of the main problem. So negative 28 times 5 will be a negative number. 5 times 8 is 40. Write down 0, carry the 4. 5 times 2 is 10, plus 4 is 14. Write that down. So it's negative 140 under 5 times negative 28. So we write down negative 140, bring down the rest of the equation, and now we have 7 minus negative 140 minus 30, but there is a bracket. So negative 140 minus 30. Let's do that calculation to the side so we don't get confused. Have too many calculations going all at once under the same place. When we're subtracting integers, we add the opposite. So now we are looking at negative 140 plus negative 30. When we add integers with the same sign, we just treat it as a normal addition problem and we keep the sign. So the answer is negative 170. We write negative 170 underneath negative 140 minus 30 underneath that bracket, and we bring down the rest of the equation. So now we have 7 minus a bracket of negative 170. Now we look at 7 minus a negative 170. And when you're subtracting integers, you add the opposite. So now we're working on 7 plus 170, which equals 177. And box your answer. Evaluate each expression if A equals 2, B equals negative 4, C equals negative 3, and D equals 5. Problem 121, negative 2 times A times C plus 7. I write down the order of operations to the side to use as a reference. Now I copy down the problem carefully, keeping all the digits and variables. So it's negative 2 times A times C plus 7. Substitute 2 for A, negative 3 for C, and then plus 7. So it's negative 2 times negative 3 plus 7. And when we have multiplication and addition, we work the multiplications first from left to right. So it's negative 2 times 2, which equals negative 4. And now we have negative 4 times negative 3 plus 7. And we do the multiplication first. Negative 4 times negative 3 is a positive 12. Two negative numbers multiplied together as a positive number. So that's 12 plus 7, which equals 19, and you box your answer. Problem 131. The perimeter of the following figure is 2a plus 4b plus 2c. Find the perimeter when a equals 10, b equals 4, and c equals 2. So we draw out the figure. Try to copy it down as well as you can. It helps if you use a straight edge, but in this case, I'll just freehand it the best I can. But I label all my sides the way it was labeled in the book. And we can see that the perimeter is the total of all the sides added together. And we can see why there's 2 A's, there are 4 B's, and there are 2 C's. So perimeter equals the sum of the sides. We copy down the equation, 2a plus 4b plus 2c, and we substitute the values given for the variables. So we have a equals 10, b equals 4, and c equals 2. I'll have to change that. I write down order of operations to the side to use as a reference. So first brackets, then exponents, then multiplication, division, and then addition, subtraction. Okay, I substitute 2 for c. And then the equation is 2 times 10 plus 4 times 4 plus 2 times 2. So we do multiplication from left to right. So 2 times 10 is 20, 4 times 4 is 16, and 2 times 2 is 4. We bring down the addition symbol, so it's 20 plus 16 plus 4, and that totals 40. So the answer is 40, and we box the answer.
If you find my videos helpful, please give me a thumbs up, subscribe for more videos on math lessons, and please share this channel with anyone you know who wants to learn math. Thank you for watching my video.